Okay, next up, I am told that I have a 0.3 molar solution of formic acid, and I've added enough sodium formates to make, the solution 0.1 molar in the salt. Calculate the pH of formic acid solution before and after adding solid sodium formates. So my acid dissociation equation for formic acid looks as follows. And so I'm going to develop an ice table. I'm told what I start with, but because there is some form of equilibrium, since this is a weak acid, I'm going to need to figure out how many moles of H3O plus I have once it does reach equilibrium. And so my initial concentration is 0.3 molar. The change will be minus x. This doesn't matter because it's in liquid. This is 0, 0. I will add x and add x during the reaction. So at equilibrium, I should have x in 0.30 minus x. And so Ka is equal to 1.8 by 10 to the negative 4. And this will be equal to HCO2 minus by H3 plus over HCO2H. And so I can rewrite that as x squared over 0.30 minus x. And this is 1.8 by 10 to the negative 4. Now note that whatever x I get from this will be small because Ka is a small value. It's by 10 to the negative 4. So if I'm taking away such a small value from 0.30, it makes practically no difference. So in order to simplify our calculations, we're going to forget about this x here because it will make that much of a difference to a very small number over a large number, 0.3 minus something very, very small. And so that means that 1.8 by 10 to the negative 4 is equal to x squared over 0.30. Solve for x as the square root of 0.3 by 1.8 by 10 to the negative 4. And I get an x value of 7.35 by 10 to the negative 3 molar. And so note the concentration of H3O plus at equilibrium is that. And so in order to find the pH, I'll just need to take the negative log of the concentration of H3O plus, which will be the negative log of my answer up here. And that will actually give me a value of 2.13 as my answer. Now for the second part, I will use the Henderson-Hasselbalch equation, and that just states that pH is equal to pKa plus the log of HCO2 minus over HCO2H. So now I am told that I've added 0.1 molar of the salt, and so I'm going to include that in this equation to find the new pH. My pKa is 1.8 by 10 to the negative 4 plus log of 0.1, so HCO2, my salt, is 0.1 molar, has been added, over 0.30. And this is going to give me the answer that the new pH is 3.26. So the pH before was 2.13, the pH after you adding that salt is 3.26. And that's going to be your final answer.